Welcome back, everybody. I hope you had a good week last week and you are feeling confident about Chapter 8, which was confidence intervals. Chapter 10 is about comparing two populations or two groups. So up until this point, we've only made inferences about a single population. Maybe we're trying to estimate the true proportion of Stat 2000 students who are freshmen. Maybe we were trying to estimate the true mean GPA of Stat 2000 students. So we were trying to only estimate something about a single population. In Chapter 10, we are going to be comparing two populations. So in 10.1, similar to how our previous chapters have been divided up, in 10.1, we're going to be comparing two population proportions. And then in 10.2, we're going to be comparing two population means. So we are still dealing with proportions and means. So we still will look at a normal distribution for proportions. We'll look at a t-distribution when we're dealing with means. But the difference here is that now we're comparing two groups. And when we compare two groups, if we're trying to compare two numbers, two population parameters, it's easier, instead of just looking at both of those numbers and saying, okay, one is bigger than the other, it's easier to look at a single number, which would be the difference between those two population proportions. So instead of just looking at P1 separately and P2 separately, so those would be the two population proportions, we're actually interested in their difference because their difference can tell us some important information. So if the difference between P1 and P2 is positive, that means that P1 is bigger than P2. If the difference between P1 and P2 is negative, that means P1 is smaller than P2. If this difference equals 0, then that means P1 and P2 are the exact same number. So we are going to be interested in the difference between these two population parameters because that will give us information about which one is bigger or if they're the same. So the first thing you want to keep in mind is that even though this has two things in it, P1 and P2, it's really just a single number. So P1 minus P2, that expression is just a single number. So we're really interested in, is that single number positive, negative, or 0? So the good news here is that we have already done a lot with hypothesis tests and confidence intervals. So now we're just changing some details about that process. So the first thing we're going to do in 10.1 is look at a hypothesis test for a difference in two proportions. So we still have that same 4-step process that we did when we first looked at hypothesis tests. And here's our 4-step process. So I know it's been a little while since we've looked at all of the details of a hypothesis test. So I wanted to kind of run through just some of the differences that you'll see now that we're looking at two population proportions instead of just one. So again, we are interested in the difference in the two population proportions. That is the population parameter we're interested in. So P1 minus P2, that is the population parameter we are trying to estimate or trying to make an inference about. So I do want to show you two different ways that you can write your hypotheses. So our null hypothesis, we're always going to assume that the two population proportions are the same. So if they're the same, then when we subtract them, that difference should equal 0. Another way we could write that is that P1 equals P2. So these two equations are interchangeable because they mean the same thing. Algebraically, if we were to add P2 to both sides, then we would get this equation here. So everything on the right side of these arrows here is just another way to write what's on this left side. So our alternative hypothesis depends on the context of the question, but just like before, we can have a one-sided test where we're looking to see is the difference bigger than 0 or less than 0. We could also have a two-sided test where we're looking to see is there a difference at all. So that would be a not equal to 0. 2 and 3 are just some examples with context, getting you to state the hypotheses based on the information in the question. So I would encourage you to look through those. The next step is our conditions. So we have very similar conditions for a hypothesis test for a difference in proportions. But because we are looking at two populations now instead of just one, we do have to check those conditions basically twice. So once for one population and once for the other population. So taking a look at our conditions here, we still have that random condition. We still have our independent condition. We still have something along the lines of n times p hat and n times 1 minus p hat. But here, our number is smaller, and we have to check it for all of those values. So n times p for the first population, n times p for the second, and then n times q hat, and then n times q hat for each of those populations as well, or each of those samples, I should say. We are using the sample proportion here. So you just want to make sure you check that for both populations or both groups. Our test statistics. So our next step is to calculate do our calculation. So we have to calculate our test statistic and our p-value. Our test statistic is in the same form it's always been in, which is this is the general format of any test statistic. Remember, we want to take our sample statistic, subtract our null hypothesis value, and then divide by our standard error. So that's what it looks like for a difference in population proportions. So here, this right here is my sample statistic. Remember, we're trying to estimate P1 minus P2. So our best guess for that difference will be the difference between our sample proportions. We're always hypothesizing that the true difference is 0. Yes, I realize that expression at the top doesn't need this, but I wanted to keep it in the same format as we always have it. So I'm going to continuously write that 0 so that we remember we're always subtracting our null hypothesis value. In previous hypothesis tests, we had you calculate the standard error for whatever it was we were trying to make an inference about, whether it was S over square root of N or whether it was square root of P times Q over N. Because we're dealing with two populations here, that formula gets a little bit messy. So we're going to just give you that standard error, or we might even just give you the test statistics. So you won't have to worry about using a formula to calculate that. That will just be some additional information that is given to you. Of course, our conclusion is the same. So remembering our significance level and our decision whether we're going to reject or fail to reject our null hypothesis. So on the next page, there is an example. I'm not going to go through this one in detail because I want to skip over to the confidence interval part and how that relates to hypothesis tests. And I'm trying to keep these videos short so that you stay focused. I know I've been having to watch 60 to 75 minute lectures in one of my classes, and it is definitely draining. So I'm trying to keep these videos short for you guys. So I am going to let you guys run through this example on your own, keeping in mind that you do have to calculate a p-value, remembering what that p-value means and how to do that in StatCrunch. So I'm going to skip over to how we compare confidence intervals and, this one's just about confidence intervals. So I wanted to skip over to this content because now we're doing a hypothesis test and a confidence interval in the same section. So we know the details pretty well at this point because we had a whole chapter on hypothesis tests and a whole chapter on confidence intervals. So now one section in chapter 10 is talking about a hypothesis test and a confidence interval. So I wanted to skip over to this part so we can get through this content, and then you guys can spend some time working through some of these examples. So if we wanted to make a confidence interval for a difference in proportions, again, remember we're trying to estimate this true difference, P1 minus P2. That is a difference in the true population proportion for the first population and the true population proportion for the second population. So just a couple of things to keep in mind when we're comparing the results of a hypothesis test to a confidence interval. We can make some important statements based on those two things. So first bullet If a confidence interval for the difference in two population parameters doesn't include 0, then 0 is not a plausible value. So think about if it doesn't include 0, and this is our null hypothesis, P1 minus P2 equals 0. If 0 isn't included in that interval, we're saying 0 isn't a plausible value for the true difference. If P1 minus P2 equals 0 is not plausible, that also means it's not plausible that P1 and P2 are the same number, because the only way this difference is going to be equal to 0 is if these two are the same. So if the interval doesn't include 0, that means 0 is not a plausible value for the true difference. So that means we should reject the null hypothesis. I talked about this a little bit earlier, but just as a reminder, if all of the values in the confidence interval are positive and we have built a confidence interval for this difference, then we can infer that P1 is greater than P2. So if all of my values are positive, meaning my confidence interval was like, I don't know, 0.1 to 0.14. Remember, these are differences that we're looking at. So if we're saying the true difference, we're 95% confident that the true difference is between these two numbers. Both of these are positive, so we can make the inference that P1 is greater than P2. If all of those numbers are negative, then the opposite we can make the inference about. So we can say that P1 is less than P2. Remember, these numbers represent differences. I can't stress that enough. So when we build a confidence interval like that one that I just written down, this is not a population proportion. This is not a population proportion. These numbers represent the difference between two population proportions. So you want to train yourself to think that I'm looking at differences now. So a positive difference means that first number was bigger than the second. A negative difference means that first number was smaller than the second. A difference of 0 means that those two numbers are equal. So number 8 is a example about a confidence interval for a difference in two population proportions. There are also a few questions here comparing the results of a hypothesis test to a confidence interval. So I encourage you guys to look through these examples in detail and make sure that you feel confident in doing each of these pieces. As always, I have those extra practice problems at the end of 10.1. So number 9 is a hypothesis test, and then asking about a confidence interval as well. And that is the only extra practice problem I have for you. But again, feel free to send me an email if you guys have any questions. And as always, I hope you guys are staying safe and healthy.